This is section 4.7 day 2, and we're going to finish up our discussion on inverse functions. Today we're going to mainly talk about composition. So how do you put kind of one function inside of the other? So before we can begin that, we really got to refresh that for our functions. For the sine function, we need to make sure that our domain, so this is domain, well, for both of these, and then our range is satisfied, accurate. We have to follow the rules. If we follow the rules, then when you compose one of these functions with its inverse, so it's almost like doing addition and then subtraction, or division and then multiplication, you should cancel each other out. That's what should happen. Whether or not the inverse function is on the outside or on the inside, if you follow all the rules, they should cancel each other out. The following the rules part is the tricky part, and we'll do a few examples of that. Next up is cosine. As long as cosine's rules are followed, which are just slightly different, the range is slightly different than sine, then they should cancel each other out. So a cosine composed with a cosine inverse should just cancel and leave you x or whatever you had. And then same when I compose them the other way. So if the inverse is on the outside or the inside, it should not matter. Same with tangent, still got to follow the rules. It's still domain and then range, but then your tangent functions should cancel each other out. They should inverse each other, and you should just be left with whatever that angle was that you were trying to take, or sorry, whatever value you had for x. And it should not matter whether or not that inverse is on the outside or the inside. They should cancel each other as long as you follow all the rules. So first one, I have a sine and then a sine inverse. They should cancel. We just got to check them. So the very first one, the way that this sine inverse is located, that's always your troublemaker, is the inverse, wherever that is located. And that's what we're going to check on to see if it's following the rules. So the inverse is on the inside, which means this is the first thing you're doing. So this is a domain right here. Range would be on the outside. So domain's on the inside, range is on the outside. This is a domain question then. So we're going to check and make sure that 0.21 is in the domain of sine inverse. So I'm just going to go look. I could look back at that table we made yesterday in our notes. So I could look here as well and just make sure that I'm in the domain, so -1 to 1, of sine, which I am. 0.12 is right in there, so we're good to go. So then these should cancel, and my answer would be 0.12. So you're checking if 0.12 is in the domain of sine inverse. And it was, so we're good to go. Number 2, I'm going to keep going. I have the arc sine on the outside, so I'm looking for the range on this one. So we're checking to make sure that 5 pi over 3 is in the range of arc sine. What this is essentially asking you is really, what is the sine of 5 pi over 3? And then what is the angle that gives you a sine of that? So they are really undoing each other. We just need to make sure that they are following the rules. So in arc sine or sine inverse, its range is from -pi over 2 to pi over 2, from -90 to 90. 5 pi over 3 is actually 300 degrees, so that's way out of our range. That is more than what we're allowed to be. We're only allowed to be -90 to 90, so 300 is way too big. So at first glance, it looks like this is not going to work. That is too big of an angle. But remember, anything in quadrant 4 we want to rename just negatively. So instead of going all the way around to 5 pi over 3 or 300 degrees, we just want to travel this way and shorten it up and just say, well, this is the same as -60. Degrees are -pi over 2. So my answer would be over 3. You could also say -60 degrees. Either of those would work. And here we had to check the range of sine inverse to make sure that 5 pi over 3 would work. And you probably want to add to your notes, 5 pi over 3 wouldn't work. It's too big. It's 300 degrees. So we just had to name it as a negative going the other way. Next up is a tangent one. So I have tangent, the arc tangent's on the inside. So that's a domain. So we're going to check the domain of tangent inverse. And the domain of tangent inverse just says that x has to be a real number. Well, -5 is a real number, so they cancel out. Answer is -5. Everything was good, so I could just cancel those two out. I could let the inverse and the regular function cancel each other and just be left with the -5. Last one's missing a parenthesis. I have a cosine inverse on the inside, which means we are checking domain. of cosine inverse. So domain of cosine inverse says I have to be from -1 to 1. Pi is 3.14, so that is not in there. So that is not going to work. So then let's check, could we rename it? Pi is 180 degrees, so to go the other way would just be -180 or negative pi. Still not going to work because -3.14 is not in there either. So since pi is not, I shouldn't have wrote equals, is not in between -1 to 1, this cannot be done. You cannot do the cosine and cosine inverse of pi. And just to doubly convince you, pi is a radian, so make sure your calculator is in radian mode. But if you were to do the cosine and then the cosine inverse of pi, you will get an error. It cannot be done. So you could double check these with your calculator if you so choose. Just make sure you're flipping back and forth from radians and degrees when you need to. But you will not have your calculator for that part of the test. So you're just looking at whether or not you're checking domain or range for each of these. If it's on the inside, it's domain. If it's on the outside, it's range. And you're just checking to make sure that whatever value you're using follows the rules. And you have all those rules right there. A couple more. These are the actual compositions of functions. So here's where we're taking a function. Well, sorry, these were compositions too. That was dumb. What I'm thinking is eventually we're going to get to some stuff that we're going to have to really work hard at to figure out the angle that goes there. This is a value on your unit circle, but it's not a tangent one. And this is not even on your unit circle. So we're going to have to do a little bit more work on these to figure out what those values are going to be. For anything that's not on your unit circle, we're actually going to have to build a triangle for. So 3/5, and remember sine only gets to be in these two quadrants. So one positive, one negative, that's it. So sine is positive in the first quadrant, so I'm going to draw a triangle, first quadrant. There it is with my 90, my theta. Sine is opposite over hypotenuse, so 3/5. If you remember, that makes this side a 4. And all I'm doing is, this was to set up the triangle, and now this is the answer. So what is the cosine of this triangle? The cosine is 4/5. That's it. The inside is to set up the triangle, and then the outside is what you want for the answer. So this one is a tangent. Tangent can only be in quadrants 1 and 4. One positive quadrant, one negative quadrant. We're negative, so that means we're down in quadrant 4, so over and down. Tangent is opposite over adjacent, so opposite is 1, adjacent is 2. The 1 gets the negative because that's the travel down side. If I do Pythagorean's theorem, I'd end up with square root of 5 out here. And I'm just supposed to give you the sine value, which is opposite over hypotenuse. So -1 over square root of 5. We know we can't have that, so we'll fix the square roots of 5. And we'll end up with square root of 5 over 5. Last one, you get no numbers, so congratulations there. We're still going to make a triangle, and if it helps, you can always put the x over a 1, and now you've got two sides. This is a cosine. Cosine is only happening on the top two quadrants, one positive, one negative. That is positive, so we are in this quadrant. So we're in quadrant 1, over and up. Cosine is adjacent over hypotenuse, and we have to find the third side. So setting up Pythagorean's theorem, I'd have x squared plus whatever this is. I'll just let it be a for right now because I don't know how I'm going to deal with that, equals hypotenuse squared. This is what I'm solving for. This is what I need. I need to know this side. So I'm going to subtract that x squared over. And then I would just need to square root both sides. So a would be the square root of 1 minus x squared. Square root of 1 minus x squared. And that was, again, just to set up the triangle. And then this is the answer. So the sine of this triangle would be opposite over hypotenuse, which is just a 1. So these are your compositions that are not on the unit circle. Going to need to draw a triangle. The middle, or the inside, is to set up the triangle. The outside is what you're giving me for the answer. And then you're going to get some that could be on the unit circle or might not, but their values, what you're given, since you're matching these up, remember this is tan, arc, tan, you just have to check and see if they follow the rules. So just a slight difference between when the trig matches and when they don't.